Let's go to page 409, and this is lesson 6.7. This lesson is to perform similarity transformations. So a dilation is a transformation that stretches or shrinks a figure to create a similar figure. A dilation is a type of similarity transformation. So what it's saying is that dilation is when you have original shape and you're going to stretch it or you're going to shrink it. Okay? A lot of times we think about dilation, we're thinking about enlarge, making it bigger. But dilation basically means you're going to stretch an object or shrink an object. And notice that this is called a similarity transformation because when you stretch or shrink the object, the image, so this is the original, this will be the image. So the image will be similar to the original. Okay? So in a dilation, a figure is enlarged or reduced with respect to a fixed point called the center of dilation. Now to simplify things, normally we put a center of dilation at the origin. So this will make the algebra a lot easier. Okay, so you want to put your center of dilation in the origin, and from there you can go and either enlarge or reduce the original to make into image. Okay. The scale factor of a dilation is the ratio of the side length to the image of the corresponding side length. Okay, so the ratio of the image to the original, that would be your scale factor. Okay. So it says in the figure shown over here, so it's the triangle XYZ is the image of the triangle ABC. So triangle ABC is original. So this is original and this is the image. Okay. It says the center of dilation is 0, 0. Okay. And the scale factor is the XY over AB. Or you can use any of the lengths. They will have this. Because it's similar, so they will have same scale factor. So it can be XY over AB or YZ over BC or XZ over AC. Doesn't matter. You can choose any of the lengths to get the scale factor. Okay, so the key concept, coordinate notation of the dilation. Okay, you can describe a dilation with respect to the original with a notation. So xy becomes k times x, comma, k times y. So k is a scale factor. Okay, so this is your original, this is your image. So basically what you want to do is you want to do something to the original by multiplying a number. Okay, so again you multiply the original with a number, the scale factor, it becomes the image. Okay. Now what it's saying is that when k is between 0 and 1, okay, again the scale factor, they just want to use a positive number. You can use a negative number, okay, which we're going to cover in the future. Okay, but right now we're going to deal with with just positive numbers. So if the scale factor is between 0 and 1, the dilation is reduction, means the image becomes smaller. Okay, so if the scale factor is less than 1, it's a reduction. If k is greater than 1, so k is like your multiplier. Yeah, that's your scale factor. So if it's greater than 1, the dilation is enlargement. Okay, so again, when you multiply a number, if a number is less than 1, you shrink the image, so it's a reduction. If k is greater than 1, means you're going to it means you're stretching the image. So I'm stretching the image, so it becomes enlargement. Okay, okay. Okay, so now let's go to example 1. So this is how you draw a dilation with a scale factor greater than 1. Okay, it says draw a dilation of quadrilateral ABCD. So you got ABCD over here, okay, with the vertices at 2, 1. Okay, so that's 2, 1, and 4, 1, and 4, negative 1, and 1, negative 1. Okay, so plot those 4 vertices, so that's what you get. Okay, and use a scale factor of 2. Okay, to get scale factor 2 means you multiply everything by 2. Okay, so look over here. So over here, see that's your original, this is your image. Okay, so you want to use a scale factor of 2 means you multiply everything by 2. So point A is a 2, 1, so multiply by 2 becomes 4, 2. So you plot that, so you got 4, 2. Okay, so that's L. Okay, and then point B is 4, 1. So you're multiplying by 2, you get 8, 2. So you plot that, so it'd be 8, 2. So that you get the point N. Now for point C, the original is a 4, comma, negative 1. So you multiply by 2, you get 8, comma, negative 2. Right? Again, scale factor is 2, so multiplying by 2. So again, you plot that point, so you go 8, negative 2. You get point N. Okay? So make sure you don't mix up with the X and the Y. Okay? This is always X, this is always Y. So make sure you go plot the point correctly. So point D is 1, comma, negative 1. So again, multiplying by 2, okay, you get 2, comma, negative 2. So you go 2, negative 2, you get point P. Okay? Now notice after you draw the image, right? If you were to draw a line, okay, notice everything will, if you connect the A and L, notice it will go through the point origin, right? See that? See, this will go to the origin. See that? If you go M and the B, see that? It will go through the origin. See that? So M, B, O. So this is point O. Okay, again, see that? So all they have to be form a line. They have to be collinear. Okay? If not, means you're doing something wrong. So you can do a quick check to see if they line up on a straight line. Okay? And also, if you notice that everything is double, right? See, from here to here is one diagonal of the square. From here to here is 2 diagonals. See that? So same thing, right? Everything is all double. Okay? So that's how you can figure out scale factor if you have to go backward. If they give you image, if you have to figure out the scale factor, you just look. Okay? The image is 2 diagonal and the origin is 1 diagonal. Therefore, the scale factor is 2. Okay, 2 to 1. So you put the image first, and then compare to the original. Okay. Another way, again, you can do any comparison. For example, like this height over here is 2 squares. This is 4 squares. So you know that this is twice as big as that. So this is 4 to 2. Therefore, scale factor is you have to reduce is 2 to 1. Okay. So you can pick any length. You can pick the distance. You can pick the length. It doesn't matter. You can get the scale factor. So again, if you look over here. See over here, this is 2 and this is 4. Again, this is double of that. Again, that scale factor is 2. Okay. Okay, let's go to the next page. Okay, let's go to example 2. Okay, verify that a figure is similar to its dilation. Okay, so a triangle has a vertices at point A, 4, comma, negative 4. Point B is 8, 2. So again, you plot the point, right? So 8, 2. This one is 4, negative 4. So 4, negative 4. And C is 8, negative 4. So you go 8, negative 4. So that's your ABC. So you can get the ruler. First you plot the 3 vertices. You get a ruler. You draw a nice triangle. Okay. Now, so that's your original. Now you have to get an image. Okay. The image of the triangle ABC after dilation with a scale factor of 1/2 is DEF. Okay, so again, scale factor is 1/2, so you multiply everything by 1/2. Okay, so over here, if you look, so this is your original, and that is your image. So you want to get a scale factor of 1/2, so you multiply everything by 1/2. So point A is a 4, negative 4, right? That's a 4, negative 4. You times everything by 1/2. So 4 times 1/2 give you 2. Negative 4 times 1/2 give you negative 2. Right? Multiply everything by 1/2. So this becomes that, and again you plot. So 2, negative 2. So 2, negative 2. That's point D. Okay? For point B, it's A, comma 2. So you can multiply everything by 1/2. You get 4, comma 1. Okay? Again, you plot that. You go 4, 1. So that's point E. Okay? And point C, okay, is A, comma, negative 4, you multiply it by 1/2, so you get 4, comma, negative 2. So you go 4, comma, negative 2. Okay? Again, how do you know if you do it correctly? Okay? Well, if you do a quick check, right? See over here, that's 2 squares on this side. This side is 4 squares, so double that. So, okay? So again, the original is twice as big as the image, or the image is half the original. So you see that? This is 2, this is 4. So this is half of that. This is 3 squares, this is 6 squares. So this is half of that, right? Now this one, the standard size is kind of hard to figure out. So you probably don't want to do that, okay? So easier to compare the base and the height, okay? And another thing you want to do is compare the distance. See over here, from here to here is 2 diagonals. See that? 1, 2, 2 diagonals. From here to here is 1, 2, 3, 4. See 4 diagonals, okay? But you don't want to compare this because this is hard to compare, okay? Okay, another way you can check is get a ruler, okay, and you line up the 3 points. See if they're on a straight line. See that? B, E, O, right? They're on a straight line. Look, check the ADO. See the ADO, again, that should be on the straight line. That should be collinear. You can check the CFO. See the CFO, again, all collinear, okay? Then, again, those are ways you can check if you do it correctly, okay? Okay, now, so again, let's go back. So sketch ABC, so did that. And DEF, again, you get a DEF, you sketch that. Verify that ABC and DEF are similar, okay? So again, you can do the scale factor, right? You can write your ratio, okay? So you can do it by the SAS, okay? SAS similarity check, right? Or you can just do the ratio, right? See AC, so you got AC over DF, okay, is 4 to 2, right? And BC over EF equal to 6 over 3, so the same, so you can check, okay? So the length of the sides including angle C, see angle C, so that's your right angle, right? So that's SAS similarity, right? Okay, let's go to example 3. Okay. Find a scale factor. So photo stickers. Okay, you are making your own photo stickers. Your photo is 4 inches by 4 inches. So that's your photo, and it says the image on the sticker is 1.1 inch by 1.1 inch. What is a scale factor or a reduction? So again, you have the picture and you're going to make a sticker. So you shrink that. Okay, so reduction means you make it smaller. Okay, if it gets bigger, it's enlargement. Okay. So again, to find a scale factor, you always compare the image to the original when you try to look for the scale factor. Okay, so the image is 1.1, okay, and the original is 4. So you can go 1.1 over 4, okay, or 1.1 to 4. Then after that, when you're doing a scale factor, you want to put in a simplest form without decimal. So what you do is just move decimal one place over, or multiply by 10. Okay, so 1.1 becomes 11, 4 becomes 40. Okay. Now another thing you have to watch out for is make sure they have the same label. Yeah? If they're inch, you have to both have to be inch. Okay. If one of the number is in foot and the other one is in inch, you have to convert them so they have the same label. So pay attention to that. Okay. And you have to know some of the basic stuff, right? You have to know that 1 foot equals 12 inches, right? 1 yard equals to 3 feet. So those are basic things you have to know, right? Okay, so like 1 centimeter equal to 10 millimeters, right? So you have to know some of the basic unit of measurements. Okay, let's go to page 411, reading diagrams. Generally, for a center of the dilation at the origin, a point of the figure and its image lie on the same ray from the origin. Okay, so again, we covered this already. See that? Okay, so now make sure that so to make things easy, you always want to have the point of dilation in the origin. It makes things a lot easier when you're doing the calculation. Okay, it does not have to. Okay, but it makes a lot easier if you do. Okay, if you just have a random point out there, and when you're going to do calculation, it makes things a lot complicated. Okay, especially for the beginner. Okay, so it says, however, if a point of origin, if a point of the figures is the origin, its image also the origin. So what it's saying is that if one of the point of the origin is an origin, then everything multiplied by 0, you get 0, right? So image will have the point also in the origin, okay? But anyway, so this is what we're talking about. See, the original and image and the origin should be lie on a straight line. See that? Okay? Okay, now let's go to example 4. Okay, so this is one of the standardized test practice questions. It says, you want to create a quadrilateral EFGH. So EFG, now H is going to be somewhere out here, okay? That is similar to the quadrilateral PQRS. What are the coordinates of H? Okay, so here's your original, and you want to get an image. So this becomes this, okay? This becomes this, this becomes this, and so this would become somewhere out here, okay? And what would that H coordinate be? Well, first you have to find your scale factor, right? So notice this is, again, to find scale factor is very easy, okay? See over here? See the origin is 1, 2, 3, so that's 3 squares. And then the image is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so scale factor is 3. So multiplying by 3. Okay, so the S, okay, S is 1, 2, 3, 4. Okay, so this point over here, S is 1, 2, 3. Okay, 1, 2, 3, 4. So it'd be 4 comma. Okay, so from here you go 1, 2, 3, 4, 5. Okay, so the point S is 4 comma 5. And we know that scale factor, okay, the K equal to 3, right? The scale factor, again, you can use this to check, or you can use this check, right? So if you do it this way, you got the R is, the distance is 1, 2, 2 squares. From here to G is 1, 2, 3, 4, 5, 6, 6 squares, right? So you can, either way, you get a scale factor of 3. So to find the H out here, you just multiply by the scale factor. So 3 times 4 will give you 12. 3 times 5 will give you 15. So answer would be C. Okay? So 12, 15 would be your answer. Okay. Now so again, the solution is down here. It says to determine if EFGH is dilation of PQRS by checking whether the same scale factor can be used to obtain EFG from PQR. Okay? So you can see that from here to here, see the K equal to 3, right? That's what we're talking about, right? But instead of doing the coordinate, you can just do the distance, just count the squares. It's a lot quicker, okay? So after you find the scale factor equal to 3, then we just multiply everything by 3, right? You get 12, 15. So correct answer is C.